So you can see my Twitter handle on there. Interestingly enough, actually a couple of days ago, there was a bit of a discussion with various smarter people than I am, like Gregor Hope and Sam Newman, etc., and Kevin. I think I sort of seen his name on the group about conversations about and events and commands and messages. So you may want to track that down on my Twitter. Some very smart people talking about it. But we're going to talk today about this idea of conversations and messaging. For those of you that don't know me, let's go back one. Hang on. This is basically the agenda. So we're going to talk about monoliths and just a refresher of kind of how we may have been used to doing commands and queries and monoliths. Then we'll talk a little bit about why the approach we may have learned to do that is more of a challenge in the world of microservices. And then actually we won't talk about queries, but we'll just talk about commands because of the time. And we'll talk about basically how we would get commands done in a microservice world, which leads to this idea of having conversations. And then we'll try and summarize at the end. Who am I? Most of this is dull. It just says that I'm old. The point I always try and draw out in talks is, I got started in speaking because I ran a .NET user group when there were no speakers. And so we had to essentially from the community say, who's going to talk about something next week? And you had to come and present. And so I got over the hurdle of the kind of nervousness and shame about presenting. Anyone can do this. I don't think I'm necessarily particularly good at it. And I would encourage you all to have a go at speaking at some point because it's a great way of honing your knowledge by teaching other people. And it used to be a great way of traveling to conferences. Now it's a great way of visiting the International Space Station. Okay. Any of you really interested in messaging? I run an open source project called Brighter. We have both a C# and a Python set of clients that help you do both CQRS and messaging between microservices. And essentially we wrap a common set of transports, RabbitMQ, SQS and SNS on Amazon, for example, and provide effectively a much more, if you like, ASP.NET MVC style or Django style experience where you just write your endpoint controller. We send you the message and you just handle it. So we're always looking for new contributors, so feel free. We're hopefully very friendly. Okay, so I want to talk a little bit about the world most of us are used to, the world of monoliths. And let's imagine I have a monolith for building a hotel system. Now, I always say I've never actually worked in hotel software, so I'm probably completely wrong about how hotel software works. And part of the reason that's why I pick it, because it means I'm not distracted by detail that I really know. But apologies to any of you who have worked in hotel software and are going, what is this? Okay, so let's imagine that I've got a typical kind of monolithic application. So I've probably got a database. I may have some kind of reasonable set of modules, it's a well-built monolith. And these modules deal with things like direct bookings. That's basically how I take bookings on my own website. Accounts, so I have repeat customers who set up an account, so don't have to enter their credit card details all the time. I can take credit card payments for your hotel booking. I've got a housekeeping system which deals with actually allocating rooms, making sure they're cleaned, fixing the shower if it breaks. And a channel manager which says, I want to deal with all these channels like Booking.com, Expedia, and I may take reservations that way. And so imagine a scenario in which, in this monolith, I wanted to deal with kind of a new booking. So typically what would happen is I've got some HTTP API and I get a post with basically the details of the new booking coming in. And I might then make a call basically to my direct bookings module to create a new booking. The module would then say, okay, fine, I'm going to write a new booking that will probably go through my ORM down to my database, where I effectively would write my rows down to the database. Then probably for a direct booking, if it was on account, what I might want to do is look up the user's account details, via the ORM hydrate some account objects, and then in my direct bookings, I'd say, right, from my account object, I want to now get the credit card information. So I pull the credit card information off and I'd say, right, okay, take the customer's payment. Presumably at some point I've got them to input things like a CVC code or whatever, so I can check that when I send it across with their address, etc. I'm probably going to call out to some payment provider externally, and then effectively I'm probably going to call housekeeping and say, hey, housekeeping, can you actually book a room for this person? That will again get written away to the database. And then I may call the channel manager and say, hey, channel manager, I've reduced the number of rooms that are now available. Can you reduce the number of rooms you're offering on your various websites? I'd probably look in the database, find all the channels that I essentially had for my hotel, and I would effectively then call the channel manager and say, decrement the number of rooms for any given channel like Booking.com and Expedia. And one thing you can see here is that we make a huge use of the fact that we have basically a shared database. So from direct bookings, it's very easy for me to get accounts data. It's very easy for me to call credit card payments and pass the information across, or call housekeeping and get it to write data directly to the database. Everything is essentially accessible to me. Even if I have modules and I respect those module boundaries, there really isn't any kind of parsing out of process that I have to do at this point. Okay. And this one becomes a bit more of a challenge with microservices. So this is what I would call a typical microservice. And I come from kind of an SOA background, service-oriented architectures. So I would think of microservices in a certain way, which is the kind of same way that Martin Fowler and James Lewis described it. And that's that really your microservice obeys some of the 4 tenets of SOA. It has an explicit boundary. That means if you want to do something in terms of writing data that the microservice owns, then what you're going to have to do is come through some kind of API. It could be an HTTP API, but that might be sending messages over, say, RabbitMQ, so AMQP protocol. It's autonomous, and that means it owns everything inside and it deploys it independently of any other service. And that means it owns its data and the data in its database, and nobody else can touch that. So there's no reaching in to get to my data. You have to come through my API. And the other two, share schema, not type, and compatible by policy, are not too important for this conversation, but they're worth just bearing in mind there are a couple of additional constraints on SOA typically. When we think about the microservice boundary, how the size of them, which often becomes a question with microservices, the best piece of advice I tend to give is to use the old SOA approach of saying, actually, your microservice is aligned to a business process. So when we think about business processes, we think around the idea of, I want to satisfy some customer journey or some operational requirement that supports the customer journey. And that generally consists of a series of process steps which will actually deliver on that value to the customer. So really the microservices are aligned around processes, and that really helps you in terms of maintenance, because it means your product team are focusing on essentially a given business process. So here might be my hotel software arranged as a series of microservices. And as you can see, essentially those large modules in the monolith may actually map pretty well to my idea of microservices. So I've got a bookings microservice, an accounts microservice, and a housekeeping one. And I've got one that is essentially my gateway to doing payments, and one that effectively is my gateway to managing my channels. And typically, I've got some sort of setup like this, where essentially my microservices can communicate with each other via messaging. We call that communicating over a bus. And I may well have some kind of gateway layer in front of my actual microservices, and we'll explain what that is for a bit later. And I may have partners or clients that want to talk to me, talk to my APIs that live outside the perimeter of my organization and have to call me by some mechanism that's just going over a perimeter. So the question then becomes, if someone's posting a new booking to me in this brave new world, it all begins pretty similar, right? They're just calling from their client to my API for doing my direct bookings. Looks very similar. Then the question becomes, well, what do I do about getting basically all the other information to process that request? I might imagine, well, in order to get hold of the credit card details, I can't reach from direct bookings into the accounts database. That's not allowed, because remember, boundaries are explicit and the services are autonomous. I can't cross the boundary into accounts database because of that. I would violate the explicit boundary, and I'd also have a dependency on a database scheme, which would mean I'd remove autonomy. So my option could be to say, well, I'm going to call the API for accounts from the client. I'll get hold of the credit card details, and I'll just pass them across then to the credit card payment system to take the payment. And once I get a response back from the credit card payment system that essentially all's well and good, I've booked the customer can afford to pay for the room, I might then say, housekeeping, okay, please reserve the room for the customer on these dates. Oh, and channel manager, you should now reduce the availability of the number of rooms. And naively, that might seem a sensible way of dealing with the fact that my microservices have these explicit boundaries and autonomy constraints. Unfortunately, that leads to a problem that's sometimes known as the entity service problem. And Michael Nygaard, who some of you may know from a really great book called Release It, named it basically as the entity service problem. And the problem becomes, if you think about the top model there, where we're talking about being bad, in a classic client-server model, what tends to happen is all of my business logic, all of my important workflow around that process of taking a booking lives in my client. It doesn't actually live in my services. And my services end up at this thing we call an entity service. They essentially just do CRUD around a given entity. So my booking service just ends up doing CRUD operations for bookings, account service ends up CRUD operation for accounts, etc. You get the picture, right? And then they end up very anemic. And if I want to change any of my business logic, I have to basically use this client to get all the work done. And the problem with that is, one of the reasons I may have gone to microservices was to divide up my work among a number of teams in the organization, and that client space is now going to become a bottleneck. And it also, in my experience, becomes a particular problem with the idea of being able to release clients. Clients are often harder to release. You know, people have to be persuaded to upgrade their phones app version in order to get the new business logic in. You have to try and force updates on them, etc. If it's third-party partners who are basically being asked to maintain the business logic, do you know they've got the logic right? How do you force them to upgrade it? So that's a pretty bad model, and we see that as kind of an anti-pattern in microservice as well. So the better model is the one at the bottom, where we recognize the fact that we said we want our microservice boundaries to be aligned with processes, not with entities. And so at the bottom, you can see we've got this idea of a direct bookings process, a payments process, a room reservation process. And we say that really the work is a flow between those various processes. So we want to say, hey, pass the request to direct booking, then it goes to booking, then it goes to payments rather, then it goes to reservations. Right? So what we'll talk about a little bit is how we build this bottom model better, rather than basically get stuck with the top model. Okay. And one of the questions that comes on quite early along in this process, it would be this. If I say, well, I want to basically take a direct booking, and then essentially as a result of that direct booking, latency, sorry, I got this wrong. What I want to talk about was latency. So if I say my post takes 200 milliseconds, and my get to my account takes 100 milliseconds, my post to credit card payments may be longer because I'm making an external call to a payment provider and they're always slow. There's housekeeping, which I own, basically takes 200, and channel manager, again, has an external call, takes another 1,500. And you can see that I'm building up a lot of latency in terms of the client. And the client effectively is probably going to sit there spinning, waiting for the response to come back, saying, please do not touch the screen during the processing of your request, etc. Don't navigate away from this page, etc., etc. Right? And that's a pretty poor user experience. It might be better from the point of view of my customer to simply take the booking and, especially as you're on an account, just email you if there's a problem, because 95% of the time I'm likely to succeed. So the only problem is going to be your credit card expired, or essentially your credit card's declined because you have insufficient funds. And in those cases, I probably want to loop back and have a discussion with you anyway about, can you go into the account, update your credit card details, try again, etc. So latency is another problem with this. Okay, so conversations. So imagine that effectively I decide that the better way to solve my microservices problems is to have an event-driven architecture. and what I'm going to use to integrate between my various microservices are events. And so when direct bookings effectively gets a message saying, please have a booking, it literally raises that onto basically the bus. And as a result of that says, hey, can you effectively send a message to other subscribers to say a booking has been made. So I take a booking and I raise something onto the bus. Now, direct bookings doesn't have to know about any of the subscribers, doesn't have to understand what the workflow is, just publishes a message. Anybody who says, I take some action on response to that can subscribe and effectively take whatever action they need in response to a booking being made. And that's where we all start with event-driven architectures, right? But there's a problem that occurs for most of us, and that's as soon as I get a message in when I post a new booking, one of the things that I may think about is, well, I've got my new booking information. Now I can send that information down to accounts or rather be to credit card payments and say, can you take a payment? And the trouble becomes is, well, how does credit card payments know how to get the account details? Because if credit card payments was to make a call across to accounts, well, that's going to be a problem. Because now I've essentially put a request-driven architecture back in here in order to get hold of basically the information from accounts. And I don't really want to do that. And that's because now credit card payments essentially is becoming responsible for the subsequent steps of the workflow. It has to understand them, which behaviorally couples credit card payments and accounts. And I also get temporal coupling. Accounts has to be up at the time I want to take your credit card payment. So I want to avoid both of those issues. So how can I kind of work around that? So my first option, essentially, if you look down on the left-hand side, would be to say, okay, well, when I send the message to credit card payments, the obvious answer is that the credit card payments message has to have all the details that I need. So it can open up that message and say, well, I have your credit card details. And that's basically quite often referred to that as a document message, right? It's basically something that contains the data that tells us how to process it, as opposed to a notification. Notification says something's happened, but I may not have all the information. You need to process it. You may have to ask other questions. Whereas a document message says I contain all the data that you need to process that. And the other option is that credit card payments actually has a cache of the account's reference data. So in other words, it has somewhere a place it can look up within its own service boundary, the account details, particularly the credit card numbers, that it needs in order to do its work. And we'll talk about that one as well. So the first kind of option we think about basically how we're going to manage the situation into the left-hand corner in terms of document messages is what we call choreography. And it's called choreography essentially because all of the microservices are like dancers on a stage. We may have sat there with a choreographer beforehand and figured out what the dance is going to be, but when they're dancing, there's nobody standing there telling them what to do. They all just basically do the thing that they have been preset out to do. And so in choreography, what I'm going to say is, well, I need to have the account details in order for credit card payments to be able to process it. So I'm going to treat this as a pipeline. And what happens is, as the message travels along the pipeline, it will accrue the information it needs for the actual data sync to be able to process it. So this case is obviously very simple in the sense that the post comes in. As the post comes in and sends the message across, accounts is the one that picks up direct bookings made, not credit card payments. And accounts says, oh, my job is to add in the credit card details. So it adds the credit card details into the account. And it then raises essentially something like, let's call it direct booking with account details. And that's what credit card payment listens to. Credit card payment picks that up and then it's able to look inside the message. It has the credit card details it needs and it's able to then take the payment. And this is a very simple system and it's a bit underused in my experience. Just simply passing the information you need along. There are some interesting things you can do if, for example, you're concerned that the payload is growing too big. You can kind of stick the payload in a bucket, say an S3 in AWS. Just stick the reference to the bucket in the message, and then you can just go into your reference app to get hold of it. Something like S3 is so reliable, you can probably choose to depend on that at runtime. But overall, this flow is a very simple way of getting something done. So, I work at Just Eat. When you're talking about an order, you can flow an order down between various microservices that all have skin in the game of processing it. But some of them can do this middle step, which we tend to technically refer to as content enrichment, which is I don't really process anything. What I actually do is add more information so that somebody else can process it. If there are errors in that process, then that's simply handled exactly the same way, right? If we can't take the payment, we just raise an event that says credit card was declined. And what has to happen is something like direct bookings has to listen for that message and say, oh, this booking, which I usually have an identifier that I can reference it by, was declined. I want to take some action. Potentially it chooses at that point to suspend the booking rather than cancel it, because the customer may be able to present a different card and pay. As a result of that, it may then in turn raise a different message, which says, well, I'm going to send a message to accounts in order to get the email address, and presumably some of that, what would happen is we'd send it to a service that would actually email the customer and say, hey, customer, can you present a new card to us? So as you can see, what's happening is just a flow of events, and there's nobody centrally controlling what happens. Each service just understands I can raise events and I can respond to events. That's a classic event-driven architecture. And the beauty of this is there's very loose coupling. Okay, I'm aware of what I listen to. I'm aware of what I send, but I don't have to know who the senders and receivers of those messages are. I just know if I get something, I know how to react to it. There are a couple of problems with this basically that you may encounter, and one of them is observability. How do I know what's happening is the question. And you could stick something called a wiretap in, which listens to these messages and says, I know what step you're at. But the trouble can be if someone phones up and says, well, where's my booking? Unless you have something like a wiretap, you may say, I don't really know. I know you made a booking. I know it, and I know it's basically action is still basically in progress in its state, but I haven't seen it. But I can't tell where it failed. And that leads us then to our second step, which is orchestration. So orchestration has a conductor, somebody who is making the orchestra dance in order to his specification. And so here we have this idea of what we call a process manager. Essentially, Saga is a common word that's crept out in the .NET space, so that's a bit technically incorrect. And the process manager is going to control the flow. So what the process manager does, it says when I get a direct booking request, I'm going to make send a message to direct booking, right? So I send a message, and so direct booking, I want you to take it. And it tends to send a correlation ID. And the process manager will start a workflow and stick an ID in it and say, this is workflow 1 or whatever, right? Send to direct bookings. Direct booking says, great, I'll take the booking, I'll store it, and I'll respond back to you. There should be a tin can on the other one. And it just sends a message back. So both of these are by messaging. It puts a message back on a queue. The process manager listens for that message. It says, oh, I've got a response from direct booking saying that booking X has been made. And it looks at the identifier, says that's 1. Looks at the process, says, oh, what's the next step? Oh, the next step is to deal with accounts. Okay. I will go and get the account information essentially that I require in order to process this, the credit card details. Great. Message comes back from accounts with a response saying, here's the details you require. Process manager says, great, now I've got basically the credit card details I need for the booking. I can now send a message to basically the credit card payments, and our credit card payments can respond and say the booking has been made, right? So it's a similar flow, but what's happening is a centralized component is taking control. We refer to this as command-oriented rather than event-oriented, because the process manager tends to be sending to a specific service that it understands will deal with the request and return results to us. As you can see, one of the things we're getting to do is develop a little bit more coupling, because the process manager starts to know about the workflow rather than the individual services. Now, it's useful because when I get an error response from credit card payments, one of the things I can do as the process manager is say, I need to basically cancel the booking. And because it sends a command saying cancel the booking and it asks for a response back from that, we know that the booking has been cancelled. And one of the reasons we may want to use a Saga or a process manager is that I can confirm that basically the work has been done. So I say, hey, you know, that booking was actually cancelled. So I know now that it's been freed up for other people to make bookings, and I'm not going to lose money because I've got some booking that effectively is in some suspended state, that rather than in some incomplete state that no one ever knows whether it's basically been finished or not. Okay. And then I email the customer basically to tell them that I need some work done. So I get some information out of accounts about your email address, and we send basically the email to you. The other really useful thing around here is that the reservations pattern often tends to show up here. Reservations pattern says, I only want to give you a window of time in order to complete the booking if you don't complete it in that time period. And so reservation says I make a booking. After making a booking, essentially I start a clock, right? And if in 10 minutes you haven't completed the booking, what happens is I will then cancel it. So for whatever reason, the user fails to complete the booking in time, they time out. And that is essentially saying, well, we're going to cancel that booking. And usually what happens is the process manager itself is effectively setting up a scheduled job to say, if at the point that I wake up, the booking is not completed, cancel it. And then it will effectively then cancel the booking for you. Okay, as you can probably guess, the only danger here is effectively the top, which is basically the enterprise service bus problem. And this is what hit us in SOA 2, which had events. And that's that effectively you get exactly the same problem we were worried about in that kind of early client server model, in that actually all of your business workflow is moving into a centralized component, the process manager living in some kind of enterprise service bus, and that essentially now has all the logic, and you end up with dumb entity services again, right? So be really careful about the kind of immediate move across basically to the orchestration pan. It seems attractive, but choreography is much more loosely coupled. And I was mentioning when I tried the other day, for example, at Just Eat, one of the things is we don't really ever know whether your food has been delivered. So we know that the restaurant dispatched it for delivery, because we have such problem with drivers actually arriving at the scene and pressing a button saying it's delivered, or effectively with some of our restaurants that don't use our courier service, we never receive notification that the food was delivered. We assume it was delivered after a certain time window if we haven't got any kind of message back saying it was delivered, because we assume you will complain, right? So we don't have to have any form of orchestration around managing failed orders. We actually just use choreography everywhere, because we kind of assume that some other process, some other business process will interrupt and say it didn't work. All right, last piece, we'll go quickly through this because I do a whole lot of talk about this. So we talked about caching. So caching just says what I'm going to do is build up basically a local cache that you can query instead. The idea is, in the API model, what I might have done was called the API for accounts, cache the account details, and then effectively use that account detail cache to answer the question rather than calling you directly. I'm going to get a low number of hits, and so what I could do is pre-populate a cache with all the account details and just directly reference that instead. And I can do that by basically listening to messages from the account system that says, I've created a new account, I've updated the customer's address, or updated the customer's billing details. And those events, as they come across, build up our cache. And then when we get the booking request coming into credit card payments as a message, it says, I can answer the question about what the credit card details are because I have that in a cached account reference. Okay. And we're done.